Hello, Glendale Community College Chem 130 students. Now we're going to learn how to write ionic formulas. So one thing you need to remember is that ionic compounds are made up of metal and nonmetal ions. The metals are positive, the nonmetals are negative, and they have to add up to 0. For example, if we have a +3 metal, we need to have -3 for the nonmetals. So we have to have them add up to 0. 3 minus 3 is 0. So we're going to make things add up to 0. Now the polyatomic ions can be found on your periodic table, just like this box here. Now you don't have to memorize them because you can always use your periodic table for exams and quizzes and homeworks, but you should get used to it. Like acetate, nitrate, phosphate, carbonate, cyanide, hydroxide, those should start to sound familiar to you, and you should think, I think that's a polyatomic ion. Another thing to remember is to keep these atoms together as a group. Think of them as a single entity, so they are stuck together as a group forever. So NO3 stays together as a group. It's very happy as a group. So don't try to separate it into N and 3 O's. It's a group of NO3. So we're going to write some formulas for ionic compounds. Again, the compound has to be neutral, meaning it has to add up to 0. Let's combine sodium and nitrogen. Sodium's charge from the first column is +1. Nitrogen is from group 5A, so it is -3. So I have 1 minus 3. That doesn't add up to 0. So I'm going to need 3 minus 3 adds up to 0. So I need 3 sodiums. Sodiums are +1 each, but I need 3 of them to give me +3 to go with the nitrogen, which is -3. So the formula is going to be Na, 3 is a subscript, N. The 3 goes with the sodium. So 3 sodiums and 1 nitrogen. You don't have to write the 1. It's understood. So Na3N is the formula. I want you to try these 8 combinations and write the formulas for them. Make them add up to 0. This is so important. So hit pause and give it a try. And we're back. So I hope you gave this a try on your own. I'm going to show you the answers, and I'm going to work a couple of them with you. Let's try number 3, K and P. K is a +1. P is a -3. So that's why we needed 3 Ks to go with the P. K3P is the formula. 3 minus 3 equals 0. Let's look at number 4. It's hard. Calcium is a +2. Nitrogen is a -3. That doesn't add up to 0. 2 minus 3 isn't 0. But maybe it's not obvious what we're supposed to do. Well, when you're in doubt, make a common denominator. 2 and 3 will meet at 6. So calcium is +2, but I need it to get to +6. So I need 3 of them. +2 + 2 + 2 makes +6 total. Now, nitrogen is a -3, but I need it to equal -6. So I need 2 of them. A -3 minus 3 is -6 total. So I have 6 minus 6 equals 0. So that's 3 calciums for every 2 nitrogens. Thus the formula Ca3N2. That's a hard one. And let's look at number 8. Pb parentheses Roman numeral 4. What does that mean? That's the charge on the Pb. See, Pb is one of those we don't know. So I have to tell you the charge in a Roman numeral. So Pb is +4 in this example. So we have a +4 and oxygen is -2. 4 minus 2 isn't 0. So I need 2 oxygens to make -4. 4 minus 4 is 0. So the formula is PbO2. Again, all you're doing is making the ions add up to 0. 1 minus 1, 2 minus 2, 3 minus 3, 4 minus 4, 6 minus 6. We need them all to add up to 0. Okay, and you write the formulas like I have there in yellow. Good job. Note, from now on, every time we have a metal and a nonmetal and we put them together, you're putting them together, you need to check the charges. That's what I'm going to call it in all the videos. Check the charges. Make sure they add up to 0. This is very important. You can't just put a metal and a nonmetal together like CaBr. That's not a chemical. You can't just put them together. You have to check the charges and make the formula add up to 0. Also, in an ionic formula, the cation always comes first, which is usually the metal because they're positive. So, for example, salt is NaCl, not ClNa. Now let's do formulas with polyatomic ions. I'll give you a metal and a polyatomic ion, and you put them together and make sure they add up to 0. We're going to use parentheses when we have more than one polyatomic ion. I'll do number 1 for you. Mg and OH minus 1 charged. Mg's charge, well, it's in column 2, so it's a plus 2. So we have plus 2 minus 1. That doesn't add up to 0. Plus 2 needs a minus 2, so I need 2 OHs called hydroxide. So I need 1 Mg and 2 hydroxides. So I could write MgOH2, except the 2 would only go with the H. How can I show that I need 2 OHs? That's right, I put them in parentheses. So I'm going to have Mg, OH in parentheses, and then the 2. Very good. All right, I want you to try the rest on your own. Hit pause, give it a try. Come on, you can do it. And we're back. I'm going to show you the answers. You can hit pause now if you need to check yourself. All right, let's try number 3 and 5. Number 3, silver, if you remember, is a plus 1. Sulfate is a minus 2. So we have 1 minus 2. That doesn't add up to 0. I need 2 minus 2. So I'm going to need 2 silvers to go with 1 sulfate, SO4 group. So Ag2SO4. I don't need parentheses, do I? Because there's only 1 sulfate group. I only need parentheses when there's more than 1 polyatomic ion. And number 5, Cu Roman numeral 2. What does that mean? 2 is the charge on the copper, because copper is one of those that we don't know. It's variable. So I had to tell you, in this example, copper will be plus 2. Metals are always plus. So plus 2 and CO3 is minus 2. 2 minus 2. Well, that adds up to 0, so I don't have to do anything. It's just CuCO3. So that was easier than expected. All right, I hope you're doing a good job with adding up to 0 here. These ionic formulas are so important. You've got to make them add up to 0. If you need to rewind and look at this section again, make sure you give it a try. All right, so that's the end of this video. We'll be back in a little bit. Take a break.